This question is increasing order search tree. So you're given a root of the binary search tree, and then basically you have to rearrange the tree in order so that the leftmost node in the tree is not the root. So yeah, so this is the idea, right? So you have to go all the way to the left, and once you hit the leaf, and then you go back to the parent, and if there is a right child, right, you have to just connect it, right? And then later on you're just doing like this, right? So at the end you will get the one-way binary search tree. Alright, so in this one we can actually just think about this, like how do we actually generate this tree? So again, you can redirect your right, the node left and node right, to reformat the entire tree. So you are still in one tree, so you don't need to allocate any space. So this is going to be my first solution. I'm going to use a same space, same tree node to reformat my tree to this one. Alright, so now this is going to be my first solution, and my second solution is going to be using the in order method. I put every single tree node into the list, and then I create another tree, and then which is starting from the root and all the way to the right, and then I will just keep pointing to the right, you know. So this is the second solution. So let's just start coding, and I'm going to just using the first solution without allocate any space. All right, so I need a function helper, so it's going to be tree node. This is because I need to point my current tree node to another one, right? So let me call what probably traverse, right? So tree node, I'm going to just say this is going to be root, and tree node, this is going to be next, but you can also say tail. All right, so at the beginning I'm going to say return traverse. So the current node is what? Is root. The next, the parent of the root is null, right? Alright, so this is going to be the, this is the entire code for the first method, and then I'm going to keep going left, right? So I will say something like this, right? Root out left, and if you go into the left, your parent should be what? Should be your root, right? So you want to keep your record when you can go right, right? So if you're going next, if you're going to your left child, right, you want to keep your access point to your right child, right? So the only way you can keep going right is what? Saving your parent, and then when you go back to your parent, you can go you can go back to the right, right? So this will be something, and then the base case is going to be what? If the root is null, you can return tail, right? Alright, now this is the tricky part. I want to go left, right? But I need to generate a tree node to what? To allocate my current position, which is, you know, the new root, right? And now I will just say return result, right? But I haven't finished because I didn't go right? So I keep going left, and I keep saving my what? Saving my parent until what? Until root equal to null. So I will return. So I will return, go back to the parent. Then I will set what? So I will set my left to null. So the left is what? The left is root equal to null. And then I need to redirect my right. So root out right, right? So I'm right here, right? Root out right equal to what? Traverse. Root out right, and this is going to be tail. So you always saving your parent. You always saving your parent access point. This is the tricky part. and let me submit. Oh, I made a mistake. Root and submit. Alright, so for the time and space, this is pretty straightforward. The time is what? All of n, access every single tree node in the tree, all of n. The space is what? Constant. Look, the reason why it's constant, you are not like creating a list, you are not doing anything else, right? So this is constant, all of 1. This is the first solution. Alright, the second solution is pretty straightforward. You're just using the in order method, and then I need to create a list. I need to just put every single tree node value into the list, and then when I poll, that when I keep going right, I will just create a tree node and then point on my right. So I can say list of tree node. I'm gonna say resort, and I can say new array list, and then I will say public void, and then traverse, something like this, tree node, no. So this should be pretty straightforward. If you are not understanding in order method, you should go back to like Google, something like this, and result.app, and I'm going to put a node and then traverse. Not right. Alright, so this is it, right? So traverse, in order traversal. In order traversal is like this, and then what else? I need to create a dummy node, right? Tree node, dummy head equal to new tree node, and then I will need to have a temp head equal to what? Dummy head. So I'm going to just I'm going to just keep basically I'm going to keep my temp head move by what? Move with the for loop inside the list. So let me just call this function first. I'm going to say put root into my traverse. This is because when you want to what? When you traverse the entire tree, right? Your root is not actually the root. It might be pointed at sometimes over here, sometimes over here. So it's not accurate, right? But now we already got what? We already got the entire tree node, list of tree node, right? And we can traverse. No, with what? Resort, right? So so I'm not moving my dummy head, but I'm going to return dummy.next, dummy head.next. Sorry, dummy head.right. This is because we don't have next, we only have left and right. So the only thing you can do is what? So dummy head, this might be easy to draw. So again, this is dummy head, this is temp head, right? So you are set this equal, right? And then I'm going to just using my dummy head, what? Keep pointing to the list of tree node, and then just keep going right, and then later on I know my dummy head dot next is what? The actual root, right? So here it is. So temp dot head dot right equal to what? New tree node dot val. So you are not allowed to put node because the actual node has left and right, and then this won't be accurate, right? Because when you want to return the answer, you are return the tree node. So somehow you will definitely get what I'm saying. So once you finish, so just move on your next pointer, which is temp dot right. So this will be the entire solution. So the only thing you can optimize is what? Put the integer in here, right? But I would like to say put tree node is fine, because you can actually determine which one you are going to use, right? So let me run it and submit. Alright, so again, if you see the time and space complexity, it's going to be what? Different, right? Because in this one, we are actually what? All of n for the time, and then we all of n again. This is because we save the tree node into a list, which is going to be space complexity is going to be all of n. N represent the number of the tree node in the tree. So all of n for the time, all of n for the space, and everything else should be what? Constant. And this is a solution. So which one you prefer? I mean, I don't know, but I would definitely prefer the first one, because the first one is actually the logic. Like, you are not allowed to reconstruct the tree, right? You want to using the same complexity to reformat, and this is the idea behind it, right? And this is the solution, and I will see you next time. Bye.